Hello there, welcome to lesson number 9 in our series on using FluidDesigner for 3D printing to create pendants. In today's lesson we're going to show you how you can create a star-shaped pendant. So if you start up FluidDesigner, first thing you need to do is to go to Learning Projects, and we're doing Jewellery Projects Pendants. We're doing lesson number 9, so we want 09 and it's a star pendant, so we drag and drop that onto the workspace, and I'll just click here to start the screencast keys, so any key presses I make should be displayed here. So this is the pendant that we're going to create in this lesson. So it's a star-shaped pendant with a connector just here. Maybe not the most elegant position to put the connector. There probably are slightly better ways of doing it, but that's where we've put it in this instance, just because it's a little bit easier than messing about in other places. So what do we need to do? Well, if we look in the help window, we're going to do add curve and curves galore to create the star shape. So add curve and curves galore to add many different types of curve. Now if we go to view and zoom to selected, you'll see that the default shape is this I-beam. This is engineering, construction engineering sort of shape. It's an I-beam, and it's a type called profile in FluidDesigner. So what we need to do is we need to change the type from profile to star. So we click on this panel here, and as you can see there are lots and lots of different types of shapes that we can create in FluidDesigner, and they all basically work along the same principle. We're going to use the star shape today, and as you can see it's changed to a star, and we've got 1, 2, 3, 4, 5, 6, 7, 8 points, as you can see in the panel here, and we're going to leave that with 8 points. It's quite small at the moment. As you can see, it's only 2 millimeters across, so in other words from here to here is 2 millimeters, here to here is 2 millimeters. But first of all, before we make it any bigger, we're going to change this value called the twist. So if I just change it slowly, you can see what's happening. It twists the center of the star, so you've got some a lot of choice there in the appearance of the star. Okay, so it's rotating it, it's twisting it around the center. It's keeping the points on the outside pretty much in the same place. It's just rotating the center of it. So we're going to set a twist of 0.3 just to give it that off-center look, and we then want to change the inner radius to 20. Well, as you can see, as we do that, we're clearly dragging the middle of the star outwards, and we want to do it at 20. So if I just drag it with the mouse, you can see what's happening. The dimensions of the object are increasing, so we're up to 30 millimeters now. We want an inner radius of 20. So if we just type that value in, 20, there you are, you can see where that takes us to. So that's pretty straightforward, I think, what the inner radius does. We now want to change the outer radius, so let's have a look at what happens there. Okay, can't see much at the moment, but it is building up. So if I just move this, drag it with the mouse, you can see what's happening. We're getting our star shape now. We want this at 10, so I'm going to type in the value 10. So there you are, we can bulk out the star. We've now got it at 40 millimeters by 40 millimeters, and it's pretty much the shape that the profile shape of the star that we need now. What it hasn't got, as you can see, it hasn't got any thickness. So we've finished with these values here. We don't need to change anything more there, so we can actually, because there's only 4 properties to change, we can move that out of the way. What we now need to do is to add some thickness to this. Now this star is a curve. Now we can't print curves, but in the properties panel there is a curve icon there. So if we show the curve data information, what we need to do is to add some thickness to this object, and we're going to do it by using the extrude value. Extrude gives us some depth, some thickness to this object. So if we click 1 millimeter there, you can see adding thickness. Okay, now if I set extrude at 5, I'm not going to leave it at that, but just to demonstrate what's happening. If the extrude value is 5, if we go to show the curve data information, you'll see that the Z value is 10 millimeters. So the blue arrow is the Z. So what we're saying is that this thickness now, total thickness, is 10 millimeters. And that's made up of an extrude value of 5. Well, 5 millimeters is the extrude value from the grid to the top, and also extruded 5 millimeters to the bottom. So 2 5s are 10. That's where the thickness comes. It is important that you appreciate that. So we're going to set an extrude value of 3 millimeters in this instance, which gives us a thickness of 6 millimeters. Now when we're happy with the profile of this and the thickness, we need to convert it from a curve into a mesh, and we always do that in FluidDesigner by going to Tools, Object Tools, and converting it to a mesh. Now the next thing we want to do is to add on this connector. Now I've tried this a couple of times in the last few minutes, and every time I bring in this connector, it seems to attach it to the center of my star. So one of the things that I would recommend here is that if we just drag the star up a little bit away from the origin, so in other words, if we look at the main information icon, I've changed the Z location of the star. I've just taken it above the origin. So if I type 0 there, that'll put it back down at the origin. If I just drag this, it'll move it up. So I'm just moving it away from the origin here. And the reason for that is it just does, for some reason, when we're using this object, cause problems. Doesn't normally, but I have experienced it here. So we're going to add this connector now. Now the connector is a built-in object in FluidDesigner that we've created for you. And what we're going to do is we're going to add one of these connectors, and we're going to add the 5x5x3 connector. So it's got, this connector has got a cross-sectional shape of 5x5, so the width and the base are 5, and the 3 refers to the diameter of the hole. Now if we drag and drop this object onto the workspace, because it's a Blender file, this work will disappear. So what we need to do is to go to 3D Templates Connectors and locate this object. And we do that by going to File and Append. Append means we can drag in an object that's been created previously and add it to our current work. So where do we find them? Well, oh, oops, I've gone a bit too far. We need to go to the folder that says 3D Templates Connectors. That's where we'll find the connectors. We're going to use the connector that's 5x5x3 rounded. And you would probably expect to go to Mesh, but it's not actually the Mesh folder you need. It's the Object folder. And this is the object that we're going to import or add to our existing work, and it's the connector that's 5x5x3 rounded. So we click Append from Library, and what that's done is it's imported, it's appended this object from the 3D Templates folder into our current work. Now as I say, I've pulled the star up here because I've been experiencing problems that when I've done that, these two have joined together and I've found it very difficult to move them apart. Now at the moment, for some reason, star is selected here, even though this object looks like it's selected. So that's the object that's currently selected. If I now click on the connector, and you do need to be clear that it's the connector that you've highlighted, if I just pull that to the right now, actually no, I'm going to try and position it over here. I'm going to pull it out in the X direction as it is in the star below. And if I now click on the star, I need to set this value here, the location of the star, I need to set it back to the origin. In other words, if I type 0 there, it will reposition the star back at the origin. And that's always a good location to work at in FluidDesigner, because we've got an even thickness above and below the grid. And that is going to be true for the connector as well. Now what we need to do now is we need to rotate this connector so that we can fit it on this edge of the star. So with the connector highlighted, and I know it's highlighted because it says connector here, I need to rotate it about the x-axis. That's the blue arrow. I need to rotate it up that way. So if I change x here, and I can change it in either way, you can see where it's going when we click on this. So that's the direction I want to change it. Once you know the direction you want to change it, you can just type in 90 and that will rotate it so that it is now lying horizontally, which is where we want to put it on the star. Okay, so we've rotated it 90 degrees. We could have rotated it 270 degrees. And that way we could have fitted it on this side of the star. So 90 or 270 degrees would have given us the same sort of effect. The fact is that the hole is now orientated where we want it. So now what I want to do is I want to manipulate this into position so that it's fitting in an appropriate place on the star. Now as you can see here, when I rotate it like that, the gap at the top and the gap at the bottom should be the same. If I drag it too far across here, you'll see that the bottom of the connector sticks out of the star on that side, and that doesn't look right. So you need to just adjust it until it just fits in there. And usually what we would recommend here is deleting the original star. Get that one out of the way. So press X, highlight it and press X on the keyboard and delete it. And then if you go to view and view this from the top, now at the moment we're in perspective mode. When you can see the back edge of the object, it means you're in perspective mode, and we would normally recommend you change from perspective to ortho. Ortho gives you a really straight, flat feel, looking down from the top in this instance. So if we click on the connector again, you can see, I can see very clearly here when it's going through, and I can modify this and play around with it until I get it into the right position whereby I've got a hole but I've not got it sticking through. I'll just move this window back out of the way. Okay, so that looks okay. So view and view it from the top in ortho mode, and also it's often a good idea to view it from the right and see what it looks like. Yeah, it's looking okay. When you look at it from the right, you can, when you zoom in, you can see that this height and this height are the same. Sometimes you might have to adjust this. Working with the grid, working with an equal height above and below it, you shouldn't have to do that. But there might be instances where you've got objects that are not the same height above and below the grid. But that's it. I've now positioned my connector. What I need to do now is to join it to the star, and we do that in FluidDesigner by using a Boolean modifier. So we click on the modifiers icon and go to a Boolean modifier. This is the mathematics of set theory from school days, and what we want to do is to create a union. We want to combine two meshes in an additive way, and I want to connect the star to the connector 5x3 rounded, and in order to confirm this Boolean operation, I need to go to Tools, Object, Tools, and convert it to a mesh. Now whenever you run this Boolean operation, you will always find that one of the objects is duplicated, so you always need to highlight it and delete it. And then I can just put that back in the center again. So there's my star with my connector on it. So I can now save this, and as is normal in FluidDesigner, we recommend you go to Save As, go up through the menu system. We're doing Pendants, so it's My Projects, Jewellery Projects, Pendants. So save it as 09 star as a Blender file. You can't print that, so you've always got to export it as a printable file format, and we use the Wavefront object format. I'm going to save it to the desktop, so it's 09 star object. And then you always need to go to Netfabb Basic, because there will be some issues with this object, particularly when we're doing Boolean, and particularly when we're using objects like stars. So if we go to project and open and go to desktop and go to 09 star and open it up, you can see we've got a warning red triangle, and there are some red markings on the object there around where that connector is, so something's going on. But what you need to do now is to go to extras and repair the part. And as you can see, there are yellow lines all the way around the object, and there are some red markings there. So those are highlighting visually where there are problems. If I just click the update button here, you'll see that there are 4 holes in this object, and there are 113 border edge problems, and there are 3 shells. But if we run automatic repair and execute it, it still looks like there are some holes, but if we click update, they disappear. So Netfabb Basic has repaired this object. We're down to 1 shell. So what we need to do is apply this repair and remove the old part. And I just need to adjust the window there. So as you can see, the colouring's all gone. The object is as we want it now. So all we need to do is to save this. So go to part and export it as a wavefront object. Export it to the desktop as 09 star repaired and save it. Oh, now there we are. This occasionally happens that we still come up with errors even when we've seemed to have fixed it in FluidDesigner. So there are some degenerated triangles which create further holes. So this has probably happened after the initial repair, but if we click the optimize button here, you've got a tick. That says that those errors have now been fixed as well, so you just export the file. So that we had to repair it in a way twice in Netfabb Basic. I don't quite know why Netfabb works like that, but it does. But now that's a fully repaired file which can be printed. Thank you. That's the end of this lesson.